In this video, I'd like to show you some traits and some properties of equations with only one variable that have just one possible solution to them. So in this equation here, 3x minus 20 is equal to negative 2x minus 5. You see that there is just one variable. There's the letter x on both sides, but there are no other letters, no y's, no z's, just that one variable. And of all the infinite numbers out there, there is only one number that can go in for x to make this equation true. So I'd like to show that to you. First off, let's say you get an equation like this on some sort of assignment or something like that, and you are going to start to solve it. So the first thing I would do is I would get the letters on one side, the numbers on the other. And so when I solve this one, I would get rid of this x term on the right. The opposite of minus 2x is plus 2x. Negative 2x plus 2x cancels. But since this is an equation, any change I make to one side, I better make to the other side. So I will add 2x to the left side. I rewrite what's left. 3x plus 2x is 5x. Rewrite the minus 20 is equal to negative 5. Now it's a two-step equation. 5 times x minus 20 equals negative 5. The opposite of minus 20 is plus 20. I'm just solving this thing here. Plus 20 over here. And what's left? 5x is equal to 15. And negative 5 plus 20 is 15. Finally getting x by itself. Divide by 5, divide by 5, and x is equal to 3. So this term, this number, the only number that you could possibly take to put in for x and make this equation true is the number 3. Well, is that for sure? How do we know? Let's test it. So let's try it. If x equals 3 is indeed true, let's try it. So let's put some numbers in there and see what we come up with. So there's the equation again, 3x minus 20 equals negative 2x minus 5. If I substitute 3 in for x there and for x here, I end up with 3 times 3 minus 20 is equal to negative 2 times 3 minus 5. Are both sides the same? Let's keep finding out. 3 times 3 is 9 minus 20. And negative 2 times 3 is negative 6 minus 5. And let's take it one step further. 9 minus 20 is negative 11. And negative 6 minus 5 is also negative 11. So when x is equal to 3, both sides are exactly the same. Both sides are equal to negative 11. So it's true, that does work out. But does it work for every number? Well, let's pick the two numbers on either side. What if I try x is equal to 2 or x is equal to 4? Does that work out then? Well, let's try. Same equation. Let's substitute 2 in there. 3 times 2 minus 20 and negative 2 times 2 minus 5. So this time I substituted 2 in for x in both cases. 3 times 2 is 6 minus 20. Negative 2 times 2 is negative 4 minus 5. Negative 6 minus 20 is negative 14. And negative 4 minus 5 is negative 9. And sure enough, negative 14 does not equal negative 9, so x can't be 2 for this equation. Both sides are not the same when x is equal to 2. How about when x is equal to 4? Let's substitute 4 in for x. 3 times 4 minus 20. Negative 2 times 4 minus 5. 3 times 4 is 12 minus 20. Negative 2 times 4 is negative 8 minus 5. 12 minus 20 is negative 8, and negative 8 minus negative 5 is negative 13, and when x is 4, this equation is not true. It is not a true equation because the two sides are not the same when x is equal to 4. So just a little a little more evidence that x has to be 3 for this equation to be true. Well, why is that? Let's take a look at that equation a little bit. What is it about that equation that makes it so that it has to be one possible solution and no others? So when we look at this equation, a couple things that we notice. The original equation, I noticed that the x terms, 3x and negative 2x, the x terms are different on the two sides of the equation. So when you solve the equation and you remove this x term from the right hand side, and I do plus 2x, it doesn't cancel away the x term over here. So I end up with an x term equal to a specific number on the right. So what does that boil down to? If the x terms on each side of the equation are different, then the equation will have just one solution. So that's one way you can tell. You look at your equation, if the x terms on either side are different, you might have to combine like terms first, but if you get it so that the x terms on either side are different, you know that that equation will have just one solution. So the last thing I'd like to do is I would like to look at a couple of examples of equations. Can we just look at these equations and identify which ones will only have one possible solution? Remembering what we just said, we're looking for equations where the x terms on each side of the equation are different. So, first equation here, negative 6x, negative 6x. There's going to be something kind of weird about that equation. And so that one is not going to have just one solution. Here, negative 7x and negative 3x, they are different. That one will have just one solution. And the last one, positive 2x and positive 2x, the x terms are the same. So that one it won't just be a single solution for x in that case. If you were to actually try to solve these, you'd get rid of the x terms and end up with 5 is equal to 4, which obviously is a false equation. That's a false statement. So in this case, this is actually no solution. If you solve the second one, going through the same process I did at the start of the video on that equation, get the x's on one side, numbers on the other, you end up with x is equal to positive 2, which is going to be one solution. One solution, just like we predicted. Here we predicted this one was not going to be a simple one solution equation. When you solve this one, you get rid of the x term over here, you get the numbers on the other side, you end up with 0 is equal to 0. Everything cancels away, which of course 0 is equal to 0, that's always true. This one will have something called infinitely many solutions. I also have videos for these two situations where equations have no solutions or infinitely many solutions. I'm going to put links on my video right here, so you can click on the links to see videos about situations where there's no solution or infinitely many solutions to equations. But for our purposes in this video, when the x terms are different on either side of the equation, you will end up with one solution. The only number that works for x to make this a true statement is x equals 2. I hope that helps. Check out those other videos if you're curious.